Okay, let's take a look at the graph of the function y equals x squared. Because if we know the behavior of y equals x squared, then we can use it as a guide to draw the graphs of other quadratic functions. And y equals x squared, right here, there's the graph of it. Okay, and we're going to take a look at its translations, reflections, steepness, and things like that. Let's get started with the vertical translations. So, if we take y equals x squared, but add a plus 5 to the end of it, then the graph will be exactly the same as this one. Nice upward opening parabola, except its vertex, it's not going to be on the point 0, 0, it will be moved up 5. So we're going to move it up 5 on the y-axis. So we're going to put it at 0, 0. We're going to put it at 0.5. Let me mark it right here. There's going to be our vertex. And it's exactly the same shape of a parabola, just like y equals x squared. So it's going to be nicely going like that. Okay, now instead of plus 5, if we add a negative 5, again we're gonna have the same shape parabola, but this time instead of going up 5 on the y-axis, we're gonna go down 5 on the y-axis. So our vertex will be over here, and we're gonna draw the parabola from here. There you go. And these are vertical translations. It moves up, moves down. Okay, let's take a look at the horizontal translations. Now, instead of adding a plus 5 after it, we're gonna add it inside the square. So we're gonna put a parentheses and put a x plus 5, and then we square it. So if we do this, again, we're gonna have the same shape parabola, but this time instead of a vertical movement, we're gonna get a horizontal movement. So if we have a plus 5, that's gonna move our parabola to the left, and our vertex is gonna be right here, 5 points to the left, and we're gonna draw our parabola from here. Okay, now the same process, but this time we're gonna add a negative 5 inside the parentheses under the square, and this will cause us to have a horizontal movement, horizontal translation to the right, and our vertex of the parabola will be right here, 5 points to the right, and we're gonna draw our parabola just like that. Again, still the same shape. All these are exactly the same shape parabola. They just positioned at a different location. Now, reflection. Until now, all of these, we had y equals ax squared, where a was just simply equal to 1. Now let's take a look at it when a is smaller than 0. Let's make it equal to negative 1. So if y equals negative x squared, then our original yx squared was over here, right? Just like we saw it here. This was the y equals x squared, but now we have a negative x squared. So this will cause a reflection across the x-axis, meaning that if our parabola is like this, it'll reflect it down under it across the x-axis. So the vertex will stay in the same place, but this time it's gonna go this way. It's gonna face down. It's just like a mirror image of it if you would flip it down. Okay, at the end of the video I'm gonna talk a little bit more about reflection. When our problems get a little bit more complicated, we have to pay attention to the order we use translations and reflections. Okay, now steepness. Until now we just used a as 1 or -1. But what if there's some other number, like 1/4 or 10? Well, this will affect it in the way it looks, its shape. So we will not have the same kind of parabola anymore. Like this, and this were all exactly the same shape parabola. But here, the parabola is not going to be the same shape anymore. It's going to be wider or steeper. Okay, here the vertex will be at 0, 0. And as a comparison, it's always good to kind of make a like this, make a comparison to y equals x squared. So this would be y equals x squared, and therefore 1/4 of x squared. If we draw it, we can see a nice visual comparison. And we can see that it gets wider, it gets less steep. So this function is less steep than y equals x squared. Now let's do the same when y is bigger than 1. Let's say 10. So if this was our y equals x squared, then the 10 will cause it to be a lot steeper than x squared. So you'll go upwards in a lot steeper fashion. So if it's less than 1, between 0 and 1, then it'll make it wider or less steep than x squared. And if the value is bigger than 1 or bigger than -1, in that case it'll be downwards. So if it's bigger than 1, it'll make it much steeper than the original x squared parent function. Now, let's take a look at what happens if we interchange the two. Here, as you can see, we have y equals x squared. Now let's take a look at it if we make x equals y squared. So in this case, instead of the parabola opening up, we will have it open to the right. There you go. Now, we had right here y equals -x squared. That made the reflection across the y-axis. So here, if we take x equals -y squared, this will cause a reflection across the y-axis. So if the original, as we saw, was here, now we can see that the reflection will be this way. And this will be a reflection across the y-axis. Alright. Now, real quick, I'm gonna make an example of when we have several of these in one function. One little thing that we need to make note of. Let's see if f(x) equals, let's say, -x minus 3 on the square plus 4. From here, since it's in vertex form, right, we can tell that the vertex will be at 3 and 4. Now, when we draw this, and if we work in a sequence, let's say we have a negative, so we need to make a reflection, we have a vertex, we need to find the vertex. We need to draw the vertex and then make a reflection. It's not okay to mix up the order, because if we make the reflection first, so as we know, x squared would be this, y equals x squared, and we have a negative, we need to reflect it. So this will be our function that we are looking at, and then after the reflection we are gonna move it to the vertex that we found. So it's not gonna be at 0, 0, but it's gonna be at 3, 4. So it's gonna be somewhere here, and now we know it's this way. Okay, now let's see what happens if we mix up these two, the order. I want to find the vertex first. I'm gonna draw it. I'm gonna ignore the reflection, so I'm gonna draw it here with the vertex in its place. And now I want to do the reflection. What's gonna happen? When I reflect this across the x-axis, instead of having the correct graph, the vertex gonna be reflected here, and I'm gonna have a graph down here. So as we can see, these two are not the same. Here we have x-intercept, and the vertex is above the x-axis. If when we reflect it, it'll move down here, and there's gonna be no more intercepts. So this is not good. Make sure first reflect it, the main function, here the x square, and then we move it to the vertex. Then vertex. Try to remember these, because the order that you do it in will give you a different graph, and one of them is not gonna be correct.